So, as we face some interruptions during the online class, I have made this video for your convenience. Based on the electrical properties, the solids are classified into three types. They are conductors, insulators, and semiconductors. Conductors are of two types. They are electronic conductor and ionic conductors. Next, the insulators and semiconductors. Here, the insulators means they do not conduct the electricity. That means the substances those do not allow a passage of electric current. They are called as insulators. So next we shall move on to the semiconductors. Semiconductors means the classification of semiconductor is as follows, that is, they are classified as extrinsic semiconductors and intrinsic semiconductors. These extrinsic semiconductors are further classified into two types like N-type semiconductor and P-type semiconductor. Nextly, let us go through in detail study of these particles, that is like conductors, insulators and semiconductors. So conductors means these are the solids those allows a passage of electric current to pass through it. They are called as conductors, which allows the passage of electric current to pass through it. That is called as conductors. The conductivity range of this conductor is lies from 10 to the power of 4 to 10 to the power of 8 per ohm per centimeter. Here the energy gap is equal to 0. What is energy gap and everything can be studied later. Firstly, just we can recall that in conductor the Eg is equal to 0, that is energy gap is equal to 0. The example for the conductors is metals. Nextly, we shall move on to insulators. Insulator means they are bad conductors of electricity. That means they do not conduct the electricity. Or literally we can give the definition of insulator or the substances those do not allow the passage of electric current to pass through them. They are called as extrinsic semiconductors. So here the passage of electric current is not allowed. They are called as extrinsic insulators. Here the energy gap in case of insulator is greater than 3 electronic volt, and the examples for the insulators are glass, rubber and plastic are the examples for the insulators. Nextly, we shall move on to the next concept, very important concept, that is semiconductors. The literal definition can be given for the semiconductors means they are solid materials whose electrical conductivity lies between the conductors and insulators. They are called as semiconductors. The conductivity range of a semiconductor is between 10 to the power of 2 to 10 to the power of minus 9 per ohm per centimeter. This is the conductivity range of semiconductors. Nextly, the semiconductors, the electrical conductance can be increased with the increase in temperature. If there is the rise in temperature, the electrical conductance also increases. Nextly, we shall move on to the type of semiconductor. As I told you before, the semiconductors can be classified into two types like extrinsic semiconductors and intrinsic semiconductors. Extrinsic semiconductors means the semiconductors whose conductivity can be increased by adding some impurities. They are called as extrinsic semiconductors. So intrinsic semiconductor means the semiconductors whose conductivity can be increased without adding any impurities by only by the elevated temperature. They are called as intrinsic semiconductor. Once again, I repeat the definition for the intrinsic semiconductor. Intrinsic semiconductor means the conductors, the semiconductors whose conductivity can be increased by increasing their temperature. They are called as a intrinsic semiconductor. Nextly, the example for the extrinsic semiconductor are p-type semiconductors and n-type semiconductors. Nextly, we shall move on to the formation of p-type semiconductor and n-type semiconductor. P-type semiconductors can be formed by adding an impurity or an element which is present in 13th group to the element which is present in 14th group. For example, you can take germanium. So germanium is an element which is present in 14th group. Therefore, its valency is equal to 4. To this, if we added an element which is present in 13th group, say arsenic. Here to the germanium we have added arsenic here. The germanium is tetravalency, that means its valency is equal to 4 and the arsenic is trivalent, therefore its valency is equal to 3. Here one germanium atom is replaced by arsenic and arsenic is having 3 electrons, therefore it will forms 4 different bonds with the 4 different germanium atom. Remaining one empty space will be present. That empty space is called as a hole, that is nothing but a positive charge. This positive charge helps in increasing the conductance of that substance. Therefore, as it is a positive charge, this is called as a p-type semiconductor. Therefore, we can tell that p-type semiconductors are formed when a tetravalent impurity is added to when a trivalent impurity is added to tetravalent substance. Therefore, so here the electrical conductivity is carried by holes, that means the charge carriers are holes, therefore it is called as p-type semiconductor. Nextly, we shall move on to n-type semiconductor. Here n-type semiconductor means these are the semiconductors which are formed when a pentavalent impurity is added to tetravalent element. When a pentavalent impurity is added to tetravalent element, what happens? Here I can take up an example for here to the germanium we have added gallium. So here gallium is pentavalent, its valency is equal to 4. The valency of germanium is 4. So therefore what happens? This gallium will be having 5 electrons. When it is having the 5 electrons, the 4 electrons will be shared between 4 different germanium atoms and the remaining 1 electron will be extra. That means it is having a negative charge. As it is having the negative charge, here the charge carrier or the electrical conductance is done by the electron. Therefore, it is called as n-type semiconductors. The formation of n-type semiconductor, that means when a pentavalent substance is added to the tetravalent substance, the one atom from the tetravalent substance is replaced by the impurity. which contains 5 electrons. Out of 5 electrons, 4 electrons will be bonded with neighboring atoms. 1 electron will be in excess, which is having the negative charge, which helps in increasing the conductance of that semiconductor. Therefore, it is called as n-type semiconductor. Nextly, we shall move on to the formation of these conductors, insulators and semiconductors can be explained by a theory called as band theory. If we take a molecule, the atomic orbitals which are present in a molecule overlap each other to form the molecular orbitals. These molecular orbitals are of two types. One is the outermost band or the outermost molecular orbital which does not contain any electron, and one more atomic orbital which is next to the outermost molecular orbitals. They are called as conduction band. This conduction band contains the electron and the outermost band does not contain the electron. The valence band contains the electron which and the outermost conduction band does not contains the electron. So that can be studied here. You can observe here. So this is what we call empty conduction band, and it is partially filled valence band. If the conductance has to be carried out, the electron which is present in this valence band should move to this conduction band. Then only the electric current or the conductance of the electric currents takes place here. Therefore, what happens in case of conductors, there is no gap or the energy gap between the conduction band and the valence band. Therefore, here Eg is equal to 0 in case of conductors. So, therefore, what happens that easily conducts the electricity without increasing the temperature or without adding any impurities or without making any changes. It conducts the electricity because no gap between the conduction band and the valence band. After this, we shall move on to insulator. In this insulator, what happens? There is a very large gap between the conduction band and the valence band. So, therefore, this is called as the forbidden band. Here, the electron cannot shift from this valence band to the conduction band. It's very difficult, or they cannot shift from this valence band to the conduction band. Therefore, there is no flow of electric current. Therefore, they do not conduct the electricity. Therefore, they are called as insulators. Nextly, therefore, Eg value, that is energy gap value, will be greater than 3 for this insulators. Nextly, we shall move on to this semiconductors. In case of semiconductors, there is small energy gap between the conduction band and the valence bond. So, therefore, what happens? Either by adding certain impurities or by elevating the temperature, we can increase the conduction in case of this semiconductor. What happens? If we increase the temperature, the electron which is present in the valence band can easily jump to this conduction band to conduct the electric current. So, therefore, they are called as semiconductors, or by adding certain impurities we can increase the temperature, we can increase the electrical conductivity. So, this completes the study of the classification of solids based on the electrical properties. Thank you.